Good afternoon, ladies and gentlemen. My name is Ahmad Reza Sadeghi from Technical University Darmstadt in Germany. Welcome to the panel discussion at CCS 2017. Last year, I organized a panel on the topic of the impact of security research in practice and also the science of security. This year, we are going to discuss with our panel and with you a topic which is very trendy, which is very hype again. As I was an undergrad student, neural networks were very much in trendy, and now they are striking back. And especially the relation to industry is very important. This is why the title is AI Industrial Complex, and the aspects of ethics that we are going to discuss, not only from technical point of view, but also from a social point of view. So we have this panel, distinguished panel. But before the panelists start to introduce themselves and their interests and their research area, I would like to thank friends and colleagues at Google and Facebook and Cisco who are not here, but they really wanted to participate. Some of them were committed, and some of them were too late to accept my invitation, and I had already 6 people, so I had to politely reject them. But anyway, I want to thank them for being so responsive to my invitation. So I would like to just start with our panelists. Maybe we start with John. Short introduction, John, please.
Sure. Hey, really glad to be here. I'm executive director of a program at IEEE called the IEEE Global Initiative on the Ethics of Autonomous and Intelligent Systems, and also an author and a writer. I've written a couple of books on AI and also personal data, and I've written some for Guardian and the Mashable.
Hello, I'm Arthur Redfern from Texas Instruments. I manage a machine learning lab there. I design algorithms, software, and hardware, usually for accelerating convolutional neural networks.
I'm Heather Patterson. I'm a senior research scientist at Intel Labs, which is the research arm of Intel. I am a social scientist at Intel, so I bridge the technical groups and the policy groups, and I go out into the field and I interview real people to figure out what factors need to align in order for technologies to be successfully situated in real-world communities with real people.
Cliff.
Cliff Wang. I work for U.S. Army Research Office as a program director for cybersecurity research, and also I'm managing the computing science division as a division director. So a lot of interesting questions in this area, and we are very interested in going forward with programs in adversarial learning, and because security and intelligence are intertwined, and lots of interesting, challenging problems. And we're looking forward to working with the community to advance the state of art.
So that means funding.
Yes.
Hi, my name is Suzanne Wetzel. I'm currently a program director at NSF in the Secure and Trustworthy Cyberspace program. I'm there as a rotator on leave from Stevens Institute of Technology. And the topic is certainly one of the areas that falls right into also the SATC mission, and so we can talk about that in terms of more details.
Hi, I'm Howie Schroeb. I'm a principal research scientist at MIT in the Computer Science and AI Lab. My background is in both AI and cybersecurity, and I've also worked as a program manager at DARPA.
Thank you. So I would say I first try to motivate the topic. At this conference, we had plenty of AI-related or machine learning-related as a subtopic. And it seems that the interest is very, very big and very large, as you also heard from Susanna and then from Cliff. So, and then after that, we start to ask questions, and then we would like to have some interaction with you, hopefully. So let me start with some introduction. The AI hype is something that all, let's say, big players are now trying to put forward. I just mentioned some of them here. Not only those who are making software, but those who have the real data. So, and they are also working with each other. For example, Facebook with Intel, because they have actually the access to data and they can provide data with technology makers. Another thing that you can observe, not only in US, but also in Europe and in Asia, is the number of startups. Especially in, for example, Germany, which is strange that there are so many startups in AI, but also in UK, or Brexit, I'm sorry. There are a number of companies that are working in different areas that they're not traditional AI areas. We have in health and finances, we have in IoT, and also, meanwhile, in cybersecurity, and this is a scientific conference, but there are a number of companies that want to make money with that. AI is so popular that people try to explain the cognitive constraints of other people. So in this case, it is rather a new life form. Even the President of the United States is not an exception here. Also, White House predicts robots may take over many jobs, which is not good. However, I think jobs would be sad, but that maybe replaces the Obamacare. Another thing is that even minions have AI aspects in them. And it's amazing that this topic is overall. There are lots of investments in that, millions of dollars and millions of euros. But most importantly, and this is what I got from Benny Pincus yesterday, is that the technology giants are paying a lot of money for those who have real intelligence to make artificial intelligence. So academia are paid a lot of money, and they have different motivations why they go to these giants. Either because there is free food there, or free coffee, or there is lots of money and impact. At least this is what they think of. Okay. Now, my first question to the panel is: would independent, and independent is written very big there, very large font, independent academic research in AI would be impactful at all when academia have no access to real data, to a large amount of data that AI needs data? Who wants to start? John?
No. I'm gonna wait till when I
let's start with Howard. Howard, what do you say?
As the resident academic. So, I mean, first of all, let me try to make some distinctions.
You
AI
need to put
is
microphone near to your.
better.
Yes.
AI is a superset of machine learning. That is to say, machine learning is an AI technique. It's not the only AI technique. And there are many techniques that are not dependent on massive amounts of data. That's simply the thing that has been gathering the most hype recently. In terms of academic contributions, where do you think all these ideas came from to begin with? They came out of academic research, sometimes working on toy problems, often working on things that were at least motivated by real-world problems. So I do think AI research in the academic setting has an impact. What was the other half of your question?
No, it's
who owns large amounts of data? Well, it depends what you're working on also. So if you want to work on, say, visual recognition, getting a corpus of a couple of million of labeled images is not a big problem right now. It's all on the web. It's easy to gain. Standard data sets are available. So I don't think that's the issue. My bigger concern actually is what we're doing with that data. Part of it from a privacy and ethics point of view, but part of it simply from a scientific point of view, that you can go to any number of conferences, see papers that I tend to think of as the look ma no hands papers. Is to say, I trained this recognizer on 2 million images, Now I ran it on some test set and I get 97% accuracy. Sounds great. What happens when you vary things? So there have been several papers that take some of those same images, introduce a small amount of noise, and the system that was 97% accurate is now 0% accurate. That's pretty scary because we don't understand that. Furthermore, none of the papers talk about that other 3%. That's where we might actually learn something. So I'm hopeful that that's the kind of question we'll start asking in academic research. And furthermore, a lot of this stuff is pretty mysterious. That is to say, we have a technique, it works well in practice, it's useful in an engineering context, but we have very little ability to predict how well systems will do, how robust they'll be, how easy it is to confuse them. And that's the kind of stuff that needs to be worked on in an academic setting.
So my bank recently is sending me lots of emails saying, please do not trust financial advisors, trust our algorithms. So what do you say to that? I mean, if we don't know what these systems are doing, can we trust their predictions of our finances?
Well, yeah. Again, that's the other big worry I have is there are some sets of techniques that are essentially opaque. And most of the modern, data-driven machine learning techniques are of that category. What you know is the system's been trained on a training set, it performs well on a test set. You don't actually know how it works. A friend of mine used this line that I just love. He said, well, look, this is essentially an interpreted program in which the synthesis was done by mysterious means and the bytecode is not unintelligible. What could possibly go wrong? And I think we ought to be asking exactly that question, but with different intonation. The joke was, what could possibly go wrong? Well, everything. What we ought to be asking is, well, what can go wrong? What things are predictable and what things aren't. I'm not about to trust my financial future to something where it's unaccountable. And that's, I think, an important thing for humans. If my financial advisor gives me bad advice, I can at least ask that person to explain their reasoning to me and decide whether I shouldn't have been fooled or that, in fact, the reasoning seemed solid, but unfortunately, it didn't turn out so well. If some, trained system gives me a piece of recommendation and I ask it why it said that, and the answer is because the weight on node 23 is 2.7, that's not a very convincing answer. And worse yet, if it goes wrong, what's my recourse? Well,
we will come to accountability.
Yes.
Susanne, you want to say something? No?
No.
You will. So,
Do you want to go ahead?
yeah, please.
So being a basic research agency, so we have fellow program managers in physics and computer science and chemistry. So one of the things our fellow coworkers say, hey, you guys, computer science, you always work on applied problems. So I think that's true and not true, because computer science, you have lots of real problems we can work on. We can actually make research real impact right now and right at the point. But on the other side, I think for us computer scientists in basic research, we ought to think about actually as independent thinkers and not only doing the data-driven research, but really looking at future, not at the fundamental levels. So that's kind of things where the power or the strength of the knowledge or the power for the future of the industry. So that's, I think, the independent computing science research still the key to the whole society. So maybe not just doing the AI techniques for today, maybe thinking something else in terms of what makes AIs not working. On the contrary, or something else. I'm just throw out a very quick counter examples of something. So that's the value of basic research, which is looking into beyond what is today and looking into something unthinkable today. So that's what is value for the independent academics.
Before we go to Heather, I just ask a question to our attendees. How many of you got a paper rejected where the reviewers say, oh, this is not ground truth data? No one? One? I don't believe you. Don't be shy. Don't be shy. I think many of you have rejected papers. So there are some more. So the camera cannot see you. Don't worry. So, and the reason for that is that exactly what you said. Independence is very important, but the data belongs to other parties, Google, Facebook, and you need to be dependent on their data. Heather.
So I'll take that 3 places, I think. First, and apologies, I'll take the opportunity to note that Intel recently published a white paper that we encourage people to read and provide feedback on. It's called Artificial Intelligence, the Public Policy Opportunity. But the first prong of that does involve the encouragement of independent academic research and government funding for that. Not only because some of the best work is coming out of academia, but because there are real social implications at times for the second question: who owns the data? Who owns the algorithms? And, we had a conversation before the panel about, potentially copyright, who owns the copyrights or the trade secrets for AI algorithms and the data they process. And I think this is a little bit of unsettled law. So what happens when a company goes into a court and they say, well, this is a trade secret or this is copyrighted, and we can't open it up and we can't share with people what the inputs are and what the processes are and what the outputs are, because that might be, it might hurt our business. There are situations in which people who may be potentially harmed by AI should be afforded the opportunity to see what exactly has been happening to them, why they are potentially being discriminated against by insurance agencies, why they're targeted under predictive policing circumstances. Because the fact is, we know that there are biases in these systems, and at times they mirror and amplify and codify biases that we all hold as people, whether we want to or not. And there's just a lot of really nice research about algorithmic bias, and I don't want to belabor that. It might be a separate question.
No, we will come to that.
Okay.
That's another part. Hopefully we get there.
Okay.
So, John, John was.
Yeah.
We can do it together.
Just briefly, I was going to say definitely a place for academics. It's a leverage effect. And there's plenty of data out there, but companies get benefits from working with academia. But if I could just comment maybe on a couple other things. It's not, when you're working with neural networks, it's not that you have no idea of what's going on. Okay, maybe there's 7 million weights, and I can't account for every single one of them. But the structure of the network, how we train it, the data we use, you understand, if you look at these long enough, you just start to get a feel for how information flows through and what you're actually capturing, where things work and where things don't. And when it comes to trust in these, I'd point out that, I get on airplanes all the time. I don't understand fluid dynamics. It's beyond me. And if I would just make one other quote on that topic, I think it was Oliver Heaviside from his cover-up method and other solutions. He has this comment: "I don't refuse my dinner because I don't understand digestion." That's not to say that we shouldn't spend a whole lot of time understanding when techniques work and when techniques don't. But it's to say we need to take a look at actually what is working and what's not working and understand where to focus our time and not just put it aside because we don't understand everything.
John.
Well, first off, I want to say congrats to Intel. That was a great white paper that came out. I was really appreciative of that. One thing, just to say it, we don't have access to our data as individuals, and this is academic in general. The sort of, if you haven't read a book, it's a seminal book I recommend you read by a guy named Doc Searles called The Intention, not Attention, but The Intention Economy. A lot of the sort of paradigms of these conversations that I have, first of all, I sympathize with my engineer friends, my programmer friends. It's very easy for me to say, not as an engineer or a programmer, can you guys just tell us everything that your program does? And a dear friend of mine who's chair of the program that I'm executive director for, he is a world-renowned roboticist, and he's French. So I'll ask him that, and he just sort of devolves into Parisian wonderful phrases I can understand. So I want to sympathize. I don't want to make it sound like it's easy. But, when you think about, we were saying this before the panel, if there's like a smarter Internet of Things, Cisco has an Internet of Things, city or whatever, and then there's a smart car that's going to be on the grid. No one thinks twice about what's the technological interoperability of those two companies and those systems, and kind of back to your point, what's the intellectual property issues? Those companies aren't going to agree necessarily, but they have modes of working those things out. Right now, for human data, the idea of consent is broken. It just is broken in the sense of it's not a form of trust to build with someone to say, either use this service and sign this consent that may be 14 pages long if you print it out, or you can't use the service. It's not good business. So we have an opportunity and a need to evolve the internet economy and also recognize that unless humans have their data, and by the way, ownership is tough, but even just access to and control of the data, then they become part of it. And that means also legal accountability, different aspects of their identity. And especially before we get to virtual reality, there has to be a real push for every individual on the planet to have, say, a personal cloud where they can say how they want their data shared. Countries like India have already started leading the way with this type of internet identity structure, as has Estonia. For me, it's just weird, and this is my last comment here because I don't want to take too much time, but when people say, like, and we've said this before the panel, it's going to be really hard to get people to adopt this, like the average citizen. Sure, but there's Alexas in millions of homes. There'll be autonomous cars in millions of people's hands. Why not have a certification or something when they take that device out of a package that says, do you understand how you own and control your data? And you can sign up and have a way to share your data in a way that provides more consent and evolves the internet economy. It's very, very economic, and it's a great opportunity to change how it works now.
Okay, thank you, John.
Can
Is
I
there?
answer?
Yeah, you short because
Okay,
we have
yeah.
to go for it.
Okay,
We
so,
need also to collab.
let me just take this also in a different direction, kind of throwing it back to the community as a challenge, because when you look at NSF proposals, NSF has added a requirement as far as a data management plan is concerned. And as we see it oftentimes, and we've all been in the shoes of writing, or many of us have been in the shoes of writing an NSF proposal, what do you put into the data management plan? And there's probably way too little attention that's actually being paid on this important document. And I think as we actually venture into trying to answer these research questions, we really have to put some effort into this also as a community. What is the data? How are we going to share it? How do we make it accessible to everybody? Under what rules and regulations? How can it be meaningful? How can we have certain levels of test beds? What does it mean in terms of the collection of the data? Another important topic is IRB approvals. What does that really mean in terms of an IRB approval if we move forward? So I think it's very important that we as a community really think about this, and as PIs and future PIs that we think about what kind of a contribution we can actually make to the community.
Okay. Any questions from your side? All the assistant professors who are writing NSF proposals? Associates? Full? Any Europeans have a question? Asians? No? Okay. Let us talk about some concern. I put Angela Merkel here because she's always concerned. Yeah. She is the whole time concerned. Yeah. About Europe, about US, about everything. So one of the concern is that what? Oh, you have a question. Hallelujah. Okay. So question.
It's not on though, is it?
Yeah, you're
Okay.
That's intention.
So yeah, I have a question on somebody who make an assumption or make an analogy with the between flying a plane and AI, right? So okay, flying a plane, I don't know about aerodynamic. That's true, but there are a lot of people in the world knows. Now, if you look at trusting AI, I don't know about what the AI, the statistical machine learning does. Neither do anybody else. So that's a big problem.
So maybe Arthur.
I guess that's perhaps where I disagree. I mean, the people who say nobody knows anything about AI are the people who probably also don't know about Hog, SIF, SURF, SVMs. People who study in the field a lot, you understand what's going on with the systems you're building. It's not that there's no clue about these things. So I'd maybe take exception to that. But
Another question.
I'd like to comment on that. I'm someone who does research in this area. I wrote a paper at Oakland about this. So I do research in this area. I don't understand how this
Can
works.
you please introduce yourself?
Sure. Nicholas Carlini, UC Berkeley.
Yeah, okay.
I study adversarial machine learning. We don't understand why these systems fail. The reason why adversarial examples exist, these distortions you can introduce to make images classified incorrectly, if we knew why they existed, we could solve them. We haven't. Well,
Short answer, and then we
yeah, just basic on that. I mean, a lot of that work, some of it's useful, but some of it's balancing a pencil on its point. In the same way, a human, if you look at an object, you think you see something, but then if you look closer, no, I really saw something different. If I give you all the coefficients, sure, you can find sequences which create problems, but I think it's a little bit of a less problem than people make it out to be.
We will come to that. Let me go further. So one of the concern is, of course, the fact that these algorithms are error prone. And this has been shown in many embarrassing situations, like fast food flop, which is, I actually think that this is a genius way of doing it, but like fooling facial recognition, street sign setbacks, and invisible panda. Panda here, panda there. Which one is the right panda? And it's not actually a panda. Yeah. So another aspect is AI can be stubborn. If you, as a student at Berkeley, do not understand what you are doing, then that means that you have a stubborn AI. So how do you solve that if AI doesn't work as you want to? Then there is a concern about AI misuse and arms race. When technology leaders become very rich, then they also become philosophers. And then they start to say, okay, like Elon Musk, they want to ban killer robots, or the artificial intelligence would be very dangerous for all of us. Of course, they also compare it to nuclear weapons or the risk of North Korea having access to these weapons. So they're going so far. On the other hand, there are advocates, like the Facebook guy. They like it because Facebook needs this kind of technology to take your data, because they like you. Yeah? And then Elon Musk starts to say, okay, Mark Zuckerberg doesn't understand what is AI. Okay? So it's not the Berkeley student, also these technology leaders who are very rich and have lots of villas and time, they say, okay, they don't understand what's going on. Then there is a roboticist, a famous one at MIT. He says, Elon Musk doesn't understand AI. So by transitivity, I would say none of them understands AI except the roboticist. Yeah. Then there are studies. Governments push a lot of money, in Europe as well, to study about artificial intelligence. It will change our lives, but it's not going to kill you. That is the result of this study that maybe cost $100,000. Yeah. But what I like is what the nation state adversary would do with this technology. And I want to cite not my friend, Vladimir Putin. Whoever becomes the leader in this sphere will become the ruler of the world. And that's very scary when Vladimir Putin says that, and that in Russian. Yeah. So the question that we partially answered is AI misunderstood and overestimated? I know that most of you are doing AI. I am also doing AI, even if I don't know how it works. But is that misunderstood? Is that overestimated, John?
To me, and I would defer certainly to you, people who work in the space and actually create the algorithms about some of the technical aspects. To me, AI is such a broad term. It's certainly misunderstood in the sense of, I think, especially in American media, There was a joke in our work for the past 2 years. Any article that was done on anybody in the work in IEEE that we're doing, and this is roboticists, programmers, philosophers, policymakers, you use the word ethics and AI, and always a picture of Terminator was in the top. And it was sort of a joke, but then it became the bane of our existence because, you know, in the article where you're talking about trying to not scare citizens, and then, you know, God bless an editor who's trying to get eyeballs to, you know, I'm a writer, I understand, but that picture automatically takes you to artificial general or artificial superintelligence issues, which are very important. And we have people working on that, you know, longer term risk. But the stuff that we're dealing with today in terms of algorithmic bias and also data issues, people understanding it, that's the type of machine learning, deep learning, and personal data issues that we're more focused on right now.
Please. Mark.
Yeah, I was just going to say, okay, yeah, probably to both, but it's what's going on? If you take just yourself as you have an existence proof yourself of what 3 pounds and 20 watts can do. That's what your brain is. And somewhere around 2050, give or take, maybe a few years here or there, for about $1,000, you'll be able to buy about as much computing power as your brain. I mean, so you have to ask yourself, what does that do and how does that change the world? So, yeah, there's a lot of hype associated with that, but if you look at us right now, I mean, we're not in the kindergarten, we're in the preschool or, pre-preschool understanding. We can solve specific problems. Usually they always reduce down to a classification problem. Neural networks are universal classifiers. I build a big enough neural network, I give it enough data, I can solve any problem that can be solved like that. You know, is the brain running that same way? I don't know. I'm not a biologist. I have no idea about this. But this seems to be a useful direction of moving things. There's probably 4 or 5, I don't know how many other breakthroughs that need to come between now and then before we build some general intelligence. So, yeah, probably overhyped right now. Maybe not overhyped long term. I would say it gets results, so I don't really call that fully hype, you know.
Okay, so that means that this question, if it's not fully hyped, that means that it is going to have a lot of funding there, because we want to understand, is it hype or not? Yeah. What do you say?
I can add something.
Yeah.
So understand that computational power is going to be tremendous. As a matter of today, machine has already beat human beings in chess playing. So from the low data perspective, low level structured machine can do much better than human beings. But on the other side, if you look at the high level decision making, so quite often classification is related to decision making. So machine decision making with biological human decision making. So what's the key difference? The key difference is that machine works in a very confined, well-defined space for the time being. But humans, we have emotions, we have characteristics, we have characters, we have beliefs, we have desire, we have emotions, and we have cultural social influences. All these things are important part of the intelligent human race and our decision making. So from their perspective, the biological intelligence and machine intelligence are quite different per se. So I don't know, maybe down the road 20 years, the supercomputers can be programmed to have individual personalities, have personal desire, maybe some cultural social influence, I don't know. But I think that's a key difference between, at least for now, the biological decision-making, classification, or whatsoever versus machine-based decision-making.
Any questions? Please, Daphne. Oh, the microphone is pushed back. Okay.
Daphne Yao from Virginia Tech. And my view is very much aligned from our panelist from Texas Instrument. There was one day I got up in the morning. My husband was jumping up and down and saying, "You got to start doing AI." And it turns out that that was the day AlphaGo Zero published in Nature, this new article talking about new generation of AlphaGo Zero that improves AlphaGo without training data. You just tell it about the Go game rules and it will just learn from self-play. And so I told him, I thought about this having out-of-box security solutions, but then for years and years, all I did was just, it's a mind game. Every few years, I met my previous colleague, Michael Littman. He's an expert in reinforcement learning. We talk about how to use reinforcement learning in security, and none of us knows how to do it. But then you just feel so making sense to see if robot dogs can use it to play soccer, so maybe we should take advantage of this for security. But then a lot of the cases, I talk to people in my own...
Maybe you come to the questions.
Right. The question is, is the security community ready for out-of-box research solutions? If we too narrowly focus on security, on corner cases, on attacks, are we ready to accept novel solutions? And if you have a choice between novelty and security, how would you balance? But then, I want to encourage the community to be more open-minded. But are we ready? Or what do we do to get more ready?
So what happened to your husband? Is he still excited? Okay, who wants to answer this? Do we know? Do we want to do security or in general? That was the question. Yeah. So is security not too narrow?
For what?
For AI.
Oh, as a topic area?
As a topic area. That was the question. At least this is what I understood. Or was it? You want to repeat everything again? No. Okay. So, okay. Microphone, please. Yeah. Sorry. We are not very AI high-tech here. Yeah.
Yeah, so, I think Ahmed said already that, there's a huge entrepreneurial movement going on right now to apply AI techniques in security research. My concern about that, and let me be balanced about this, I think in most cases, you have to think about things both as an engineering technique and to some degree as a scientific question. So are the techniques we have around today useful for solving certain security problems? The answer is obviously yes. Are they a panacea? No, because at the scientific level, we actually don't understand very much about any of it, whether it's neural nets or logical reasoning. There are certainly cases that we know of where applying AI techniques, machine learning, and so on has been helpful. But they have the same drawbacks as things we do when we're not using those techniques, that is, when people do things. So if you train a system on past examples in a field where things are dynamically changing, you may get lucky, you may not. How much are the past examples representative of the attacks you're going to see tomorrow? Well, we've been for years building systems that can recognize signatures of known attacks. We can do that more automatically now using AI techniques, but you still have the same problem, which is if the phenomenon isn't very stable, then the ability to detect attacks that are very similar to known attacks is not very useful in detecting attacks that aren't similar to the known attacks. Does that mean it's useless? Absolutely not, because most of the attacks you see are variants of the known ones. And you'd be stupid not to use something that can help you detect those. However, it's not going to solve the other problem, which is what do we do about 0 days or novelly obfuscated attacks? So as an engineering matter, we have techniques that are useful. They're less than perfect, but that doesn't matter from an engineering perspective.
Let's go to the next question. Sorry, I don't want to interrupt you, but please.
Thanks. Hi, my name is David. I'm from TU Darmstadt, Germany, PhD student. I am not an expert in AI. I don't actually know anything about AI, but I've read a couple of books, and the question I would ask myself regarding to this question is AI overestimated? When you see AlphaGo and you think about this statement by Putin, what you could easily imagine is, a nation state takes this kind of AlphaGo and defines a new game and says, okay, you have the stock market, you have companies. The goal is to make Russia the winner. Here are the rules, and then you give it access to real-time stock market data and see what happens.
But this is already happening. Where are you now? You are sleeping.
Yeah.
Okay. So I think You are a government representative. You want to answer this question? Okay. I think nobody wants us. I mean, governments, of course, can do everything. That's a good point. Please.
Hello, I have a similar question. I'm Kaur from a small country of Estonia. You showed us some great leaders of the humankind on display here. Do you think that the nation states actually want the academic community or public to understand or correctly estimate AI? Maybe it is the interests of governments, agencies to keep this away from us, and therefore they want to downplay this so that we don't work on this, but they do.
Conspiracy, please.
Well, first off, I know you aren't a formal representative from Estonia, maybe, but I was in Tallinn about a month ago and loved it. The work that Estonia is doing on privacy and EID, and also they have this thing called X-Road, from my understanding of Estonia and its citizens, and I was also in Estonia when it was still part of the Soviet Union in high school, so I'm dating myself. But in 1987, we were thinking, it's heartbreaking that these Estonians can't have independence where they obviously want it. But because in one sense, and by the way, thank you for letting me talk about your country, you kind of could create your own identity structure. From my understanding, I went to this great conference called the My Data Conference, and they have an amazing set of principles. It's some of the most forward-thinking, and Wired did a love piece article about Estonia in terms of citizens actually do know very much about how their data, they don't necessarily know the articulated granular aspect of how their data is used in AI necessarily, but they have a hand in their identity being tied to how their data is shared, and they're empowered to do that, and then it's closely linked to things like Internet of Things services. I don't think I'm answering your question at all, but I just wanted to say so people know that Estonia is doing what I think is some of the most groundbreaking work in how data is exchanged to help government, to help business. It's not anti-business, quite opposite. But it is something where human data is articulated as part of a node that's exchanged, sometimes through blockchain and other ways, where then it's a lot easier to address things like cybersecurity because people's data isn't just sort of floating around in second and third and fourth party data brokers.
So the next travel for tourism will be to Estonia. So that was the purpose of this. We get provision for that. Maybe you want to go, and then lady.
Yeah, Neeraj Gupta from UTD. So my question, I don't know how far we are away from this, but what happens when instead of electronic circuits, we have chemical or organic circuits, and instead of Boolean logic, we are able to play around with multiple valued logic.
Arthur, you want to say something? You are not biologist, I know.
I'm substrate agnostic. It doesn't really matter to me. I mean, okay, certain computations just run better in certain on certain substrates. I mean, okay, if you ask me to add together 1 billion numbers, it's going to be a long time. Okay, my brain's just not wired for doing these kinds of boring tasks. But the computer doesn't mind doing that, and it's the right substrate for doing that type of stuff where you need exact decisions. Maybe other substrates lend themselves better to other types of computation, and maybe those types of computation lend themselves better to the types of things you want to do in AI. Sure, nothing against it.
But that's good for interdisciplinary research.
Yeah, that's what I'd say. This is the point of having academia.
The security people cannot publish their papers anymore. They need biologists for that. So, please.
So we have these different overlapping communities at the academic research community, the industry research community, and industry boots on the ground, all of whom are using AI to some extent, but do all these people have the same understanding of AI? And if so or not, is that an issue?
So we need one academia and one industry. I can tell you, no, they don't have the same idea, but that's my personal thing. Howard, do you want to say something?
Yeah, I don't think it's a problem. I think it's probably a virtue. If you want to make a machine learning system work of the kind that Arthur works with, you're much better off talking to him than to me. If you want to ask questions about, what the, for lack of a better word, the stability of that system is, where are its corner edges and so on, then the ultimate answer to those kinds of questions will come more out of academic research than out of the practitioner world. But you need to do both. And, Arthur talked about having a feel for the systems, which I'm sure he has. What we would like to do is make that kind of feeling something a lot more rigorous, so
Okay.
that you can actually make real predictions about where systems will work and not.
Sorry.
Hi, Rakesh Verma, University of Houston. So I want to go back to a point from Cliff. So what is the role of emotions in intelligence, right? I think Marvin Minsky wrote that the computers will never be as intelligent as humans because they don't have emotions. And so what do you think about that? And also a second question to that is, I believe true intelligence, human intelligence, comes from social interaction. So if computers are made of chemicals or biological molecules, will they be able to interact socially like we do? And will they become as intelligent as we do?
Poor Cliff, this is a very
That's
philosophical
interesting question, and actually, I'm also thinking their directions. So I can't answer lots of things you asked, but I think in terms of intelligence, there's at different levels. If you're just doing a chess playing, it's a very confined intelligence. But human being, as we stand here, has much more complex, multidimensional, and social relation based kind of intelligence. So if you look at the decision, that's why I say, intelligence in the form of decision making. In the machine, it's really computational based decision, but in the human, you have more than your brain doing maybe some hard computation, maybe some soft computation, and then the emotion, your desire, your culture, your beliefs, all these things, like a soft side constraint come into the play. So that kind of things, I don't think we have a good modeling or programming or computational control of that, and that's where the machine AI does not have any of those.
Maybe,
and maybe that's the differentiation.
Maybe we do one question and then we go further because there are. Sorry, just one question. You want to say something, please?
I just wanted to jump in on that. I can't speak to how much AI systems have emotional intelligence or what that would mean, but I would also challenge us to think about what happens to human beings when we think that we're interacting with beings that have some sort of intelligence that is similar to our own. I would direct your attention to a really interesting short piece in this month's November-December issue of MI Tech Review. There's a nice article about soldiers in the Navy and the Army having real emotional responses when the humanoid robot firefighters on their ships, blink at them and have facial expressions that appear to make them seem as though they're emoting, or the tactical robots to detect and disable IEDs dying, and these soldiers are giving them names and likening them to pets, and really just having an emotional attachment. As humans, we have a tendency to anthropomorphize just about everything. How many people in here name their cars, for example? A few.
You name your car?
You don't name your car?
No, my car is called BMW. Okay, so please, that's the last one, and we go further. We want to go to privacy and crypto and nice stuff. Okay.
Jayan Rochester Institute of Technology. So AI applying to computer vision and cybersecurity has a lot of differences. One big difference in my mind is that, computer vision, we look at chair, we look at light. We human beings know what that means. We can make mistakes, but this is very easy to comprehend. Cybersecurity, we human beings don't understand as well as looking at these objects. So given that, I want to hear your panelists' opinion about, so what do you think about really that this earlier question about applying AI or machine learning to cybersecurity? I think there's a big difference. That big difference is coming from our own human beings' understanding of the subject matter. So your thoughts?
John, do you want to say something?
I was assuming about emotion, but this is not.
Okay. Anybody answer to this? No?
I'll say something quick.
You say, okay. Then we go further.
Yeah, let me just repeat something I said before. As an engineering matter, we have techniques that are useful. You said humans don't understand the cybersecurity problem. Well, if we make an AI program that doesn't understand it as well as we don't understand it, that's useful. It hasn't moved us ahead, except maybe as a force multiplier. And I think you're right that that's different than trying to model perceptual processes, which are different in character.
Okay. So let me go to other aspects, which is more relevant for this conference, not biology, but more security, privacy, and then we go towards ethics. I would like to mention a scenario, and this is what Howard and I were discussing before the panel. So Tesla and AMD might be working together on a custom AI chip, and as I mentioned, Elon Musk is propagating against AI. And I'm very excited to know if any AI will be built in Tesla or not, and I'm sure that this will be, and that's when we have typical AI exploits. This is the typical problem that we are trying to solve in these conferences. And I call them the self-suicidal cars, and this would be a Tesla scenario when there is an exploit of autonomous or I call them self-suicidal cars. And you can also call this attack Ericsson attack against Tesla. But in general, this is one of the cybersecurity aspects. How can you compromise AI? Another thing is adversarial AI. We discussed that. We talked about it. This is when the the data is malicious or wrong, or the model building is wrong. And there is another thing I call it adversarial glitch in AI, because there are in many cases, at least I know it from US and I know it from Europe, where the potential of being a criminal or being a terrorist is estimated by these algorithms. And if one day they will be common sense and used as a proof in a court, can you use glitches, the problems of all these layers of neural networks, to fabricate proofs against people? Think about it. I mean, the writer of Minority Report, I'm not talking about Tom Cruise, I'm talking about the author, has a good point here. You can fabricate these things. Now, I would like to cite John McCarthy, who says that a feature, I mean, every intelligence features that can be precisely described can also be simulated by a machine. So you can simulate the whole thing. So, and how, I mean, the question would be, is it possible at all, to build an AI system resilient to adversarial inputs and simulation? So you guys, I think most of you are doing kind of AI research to get money from NSF or from Cliff, but you should have thought about that. Any idea? I can ask panelists, but I can also ask the participants. No idea? Can we build such a system, resilient against simulation? Anybody have thought about it? I'm asking the attendees. You want to answer?
Are you asking human beings never get sick again?
Yes. Raquel.
I think that this is obviously, we've been discussing over the past couple of days that this is very much an open problem. I think that an understudied aspect of it is the opportunity. We tend to think about it, it seems like in this community particularly, that, we take the view of trying to defend the machine learning system, and that's the thing we're trying to do. But when you look at it from a privacy perspective, these adversarial inputs provide a lot of opportunity. So I think I'd be curious of the perspective of the panel of the sort of weaknesses and blind spots of AI as an opportunity for enhancing privacy and allowing people to hide from AI when they don't want it intruding on their lives.
That's a good point. That's a good point. Maybe deception.
Okay.
We will come later.
Okay.
We will come. Any answer to this research question? I think this is a very good question. If not, write it down. Next paper, next ACM CCS. Oh, you want to? But quick, yeah? And no husband. Okay.
Is now the full professor at Virginia Tech. In this keynote, after the keynote on the first day, the topic is hotly debated among me and my friends. I do want to say, have a reasonable expectation of the security for machine learning systems, and so in any case, very well carefully defined the threat model probably would not be reasonable to expect it to be bulletproof. And as a matter of fact, nothing is bulletproof. In that regard, I would. And so sometimes it's dangerous to say certain category of approaches are vulnerable because there's a potential for certain specific attacks. It's everyone is insecure. Everything is insecure. It's only with respect to specific threat model. So just I encourage the community to be more scientific in the discussion. Basically, do not reject paper to say, oh, this is, there's a virtual machine learning, not all of this is junk.
Okay, so that's a cry for don't reject my papers, yeah? Okay, so,
Yeah,
but this is a very good point, but we know that this is a flaw in our community, that security people are very harsh with papers, and now we have a question there. Please do it fast.
Hey, Ahmed, sorry I came late. Going back to the previous question about building resilient AI systems, I don't know if I have an answer, but just to think of an analogy, in terms of communication systems we have, in terms of wireless communication systems or even wired communication systems, we know there's always going to be bit flips. But we've developed theories and systems to deal with that, and we can communicate. And I think same challenges with circuits. As you scale down the transistors, we know there's going to be errors. We deal with it. So I think in terms of building resilient AI systems, yes, you take any single node, it'll make mistakes. It'll fall prey to adversarial samples and stuff. But I think over time, we'll learn to build systems using those just as a building block. Overall, does probably the right thing. So that's just an analogy.
Yeah, I wanted to make a quick comment. About a week ago, one of my PhD students was in my office with his 1-year-old kid. And the kid had a coin that rolled down a grate to the ventilating system. And my student took out a key, wedged up the grate, got the coin. And the kid looked at him and goes, he's a little pre-verbal still. He gives him the key. The kid sticks the key in the thing and tries to raise the grate. Okay, so one example, he learned what his father had done. Second example, he learned he couldn't do it because he's not strong enough yet. So first of all, there's a whole different kind of learning than things that depend on millions of examples. These are all one-shot learning things. They depend on the ability to reason about and model the world, or yourself for that matter. And when things go wrong, you can fix them. You can be resilient because, again, you can reason about what went wrong and then try something slightly different. None of that's meant to criticize the kinds of machine learning that involves learning large numbers of samples, because after all, this kid is looking at the world and perceiving it without understanding what's going, how would you do that? If we think about how we work, this is an example my friend Pat Winston uses all the time. If I reach out and grab this glass, I have no idea how the motor control of my fingers is working. It's been trained by, lots and lots of experience. It's pretty damn good at it. But I can't explain to you how my arm worked, that, I had to get it over here and that I had an intention and so on. So we as humans are combinations of both things that are working at a very different kind of level that is not accessible to introspection, and at the same time working at other levels that are open to introspection and reasoning. To make systems resilient, I think we need to be doing both of those things.
But I think what Daphne said is very important for security community, especially when they do research. What is the adversary model? What is actually I'm going to achieve with what I am doing in specific?
My point was that if you take the father giving the example of what is adversarial learning, well, big deal. The kid figured it out.
Okay, let's change to. Oh, you want to say? Please.
I was just going to say, just in response to the questioner speaker on my left, it was we build resilience, and it's exactly what you're kind of thinking of or where you're moving to. If you take a autonomous car or advanced driving assistance for a car, we have cameras all around it, but we also have radars. We also have ultrasound. And it's not we're just running one algorithm. It's not like one miracle algorithm does everything. We're running all different types of algorithms, and we're looking across time. And it's a combination of things. And it tested across scenarios to build resilience into this.
So the next topic is on privacy, and I think that would interest a number of you, because usually when you use social networks, media, think about it. So Facebook has around 2 billion subscribers. This is what I think they announced some time ago or recently. Now, and many of these subscribers, they really believe in Facebook. They put everything there. Compare it to big religions. How many religions you know that could make so many subscribers in so short time? None of them. So if AI is used then, and this is where we know all that they need data, they eat data. What happens when currently we are not really customers, we are products because we don't pay, we just pay with our data. This is one problem. Let me introduce you to Kayla. Kayla is a doll. Who knows Kayla? Who plays with Kayla? None of you? Oh, come on. Please, the camera, please. Okay, you work with Kayla. That's good. So Kayla is a doll that can talk and is very smart because it answers. It was hacked. And then German government decided to forbid Kayla. If I take that Kayla from US, because I can buy it here, and I want to buy it here because for my lab is important, we like Kayla. So, and many of my students, they have no friends. So now the question is, why so harsh? Why so harsh? So we are in a democratic country, yeah? But then we have a club of friendly creatures, Alexa and others. And actually this is another Kayla, which is in our homes currently, at least in my lab. Sometimes I get really scared when our students are working with these devices, because when I come into the room and say something bad, then the device says, oh, I don't understand you, because I said some curse or some bad word. In general, the question is why these things are not forbidden. I mean, nobody forbids these things. But they don't have camera, but they can be connected to a mobile device with the camera. So the question is, how can we verify that AI algorithms are privacy preserving? How can you, verifiable computation is a nice thing, fancy, but privacy preserving, and privacy community put a lot of effort in making privacy technologies. Susanne.
Sure, absolutely. And I think we've heard a number of talks, and also in the keynote, it was certainly addressed. We are investing money in advancing privacy-preserving techniques, and hopefully we will make many more advances on this as well. Still, I would question as to whether this is ever going to be sufficient. And you brought the example with the doll. That it was forbidden, and others that are similar are not. So maybe we have to strike some kind of middle ground here. But my opinion on this side is that I don't think that we will be able to just get everything right and sufficiently well done with just the technical side. I believe that we need some sort of a policy at some level, and the question is, how do we strike the right balance?
So especially, John, I would like to mention the GDPR, that's the new European General Data Protection Regulation, which will be enforced in May 2018. And any company that does not comply to these regulations should be fined. This is at least the theory. John.
Yeah, it's not the theory. That's what the law says. One thing about these conversations that just drive me crazy is in America, it was only 2 years ago where we had access to our medical data. So I'm going to shift and say privacy. A lot of times we can talk about it's just to improve advertising algorithms to get a better pair of shoes and whatever. Well, it's a life or death issue in terms of having access to your medical data. And this is not just about ownership of data. And I want to be clear, I'm not interested in demonizing any organization, because that's not the point. We must move away from the privacy word. It's a not accurate word in terms of symmetry of data. I don't know programming, but if someone was like, hey, John, can you do an experiment with AI? And I knew I had to have 1 million photos and I had 4, I would understand. I'd be like, don't we need more than 4? Right now, you can't, 2 years ago with COPPA, you were allowed to finally get access to your data, but access to data as an American for medical situation means 15 different hospitals allow you through like XML or whatever to maybe get access to your data. Most of the time, you still get data about your kids or your wife or your husband's health through a fax in 2017. We're allowed to get angry not at the organizations, and this is not anti-business. We're allowed to say in 2017 in the United States of America, why can't I get access to my medical data so I'm not carrying around a stack of paper to try to save one of my loved ones' lives? Stop the conversation about privacy in the sense of, well, what do you want to do with your data? What do you want to do? Everyone needs to be allowed to access, not necessarily own their data and have a copy of their portable data to go place to place.
Please, question.
Good. This is Ram Dantu from University of North Texas. The question is, I did my PhD 25 years ago. Now you can judge my age, actually, so, but it's okay. That time I did in robot vision, and we had neural networks at that time. We had AI at that time. Now, today, what is the difference between a human-to-human communication? How is AI helping us? For example, President of the United States, can he call Alexa and ask, hey, how can I talk to President of China or Russia? So how can it help the human understanding and communication? That's one thing. From 10 years from now, we should keep thinking about it, I think.
Heather, do you want to say something? You work with...
I'm honestly not sure I understood your question.
Human-machine interaction. Yeah.
Well, I was just going to say human to human is, I think, if not now, within, very short number of years, you're going to have real-time language-to-language translation across different languages. I was the dumbest person in my French class always growing up. I have no ability at it. But it would have come in handy then, when I'm trying to order a quiche or something like that when I'm in Switzerland. So, yeah, I think it helps. AI has places to help there.
It's not just the language barrier. I think it's a misunderstanding, miscommunication. I know there are a lot of experiments going on in the universities, the brain-to-brain kind of interface. It's not just a human to brain to machine. It's brain-to-brain interface. So what is that will AI can help in understanding between humans? That's what my question was.
On the brain interface right now, just being sort of specific, you have a issue with information going from brain to outside of skull, dampened by the skull itself. And from an information theoretic perspective, you have to embed a lot of things actually into the tissue to get good localization and good signals. And then that's not something a lot of people want to do. So I think having EEG skull caps may be practical for a general population, but much more limited in what you can actually do in the direct brain-to-machine interface.
We will come to something that you may be interested in at the end of the session, but let me continue with privacy aspects and also discriminatory aspects. So we talked about Alexa. If you have, let's say, German accent, South American accent, and you don't know what happens to all this data, that's when people talk to their friends, like Alexa. And it can be used for many kind of discriminations or financial obfuscation. All these kind of things can be done, presumably with AI can be done. And can we make this algorithm, algorithmic accountability is now a line of research, but my problem with this kind of line of research is, what are the challenges to make an algorithm accountable? Because we have laws, accountability, what does it mean? You need to go to a court and prove that your algorithm has made a wrong decision. If you look at the real estate problems, look at the trial, City Connecticut against the US government, you will see that people who made the algorithm for real estate and win-win stock market, they even didn't know at the end how these algorithms are working. So how can you make a complex financial algorithm accountable? I don't think that cryptography helps you. Any idea? Research community, no idea?
Well, I think one thing is economic incentive. I think I'm only talking again because no one else raised their hand. I don't want to talk too much, but you know, the idea of innovation being that you have to create things as fast as possible because you can. I don't mean this community. I mean for technology in general. Where you can also say that innovation can be, how do you prioritize human well-being, where well-being is actually an economic indicator. Things like the OECD has their Better Life Index, the UN Sustainable Development Goals. Exponential growth is sort of a GDP-led innovation. There's all these wonderful organizations I mentioned too. The World Economic Forum is another one, where if you say triple bottom line, how do you make technology where it allows companies, and by the way, it's not like they're not doing it now, companies and organizations to say, it's not just that I want to do the right thing, meaning help society or whatever. I'm actually held responsible as much for taking care of the planet and society as I am for my fiscal numbers. Right now, it's in general, and again, this is not to demonize companies. We have to help the companies and say, it's not fair to say to a company, you should not like put people out of jobs by the AI you're creating. And then in the same thing, when you walk into your shareholders and they say, are you growing exponentially? Not just are we making profit, but are we growing exponentially? There are things that you can't do two things at the same time. You can't serve two masters. You can't have exponential growth based on GDP and financial factors and prioritize human well-being.
So I have a next question is, should we regulate AI? Because as you mentioned, Intel, you mentioned it before, has already recommended, let's say, public policy principles for artificial intelligence.
Yeah.
How does it work?
I think that it's a really important question. So to build off of John's comment a bit, I think we embrace the notion of distributed responsibility. AI ethical issues are not just something that we are interested in as a company because it will be important for our bottom line. I think these issues have really captured the hearts and minds of the researchers there. And it's incredibly important that the academic community, the research community, that government organizations, that civil society groups are all talking about how to form a good, accountable systems for how algorithms are designed and how they're deployed. And I think at both steps, you know, for the designers and the testers of the algorithms to do what you can do on your end, to do things like, you know, take privacy into consideration, to build privacy in by design at the outset. So thinking about OECD guidelines like data minimization and purpose specification. Those things are challenging in an AI environment, but those are important conversations to have. But then on the deployment level, once an Alexa or a My Friend Kayla is in your home, look at how that is actually influencing the people who are interacting with it. What sorts of data may be collected about them that they aren't aware of? Where is that data going? How is it being processed? How is it being used? And where is it going next? And John, you're right. We, meaning the world, we have not provided end users with meaningful tools with which they can control their information flows. So there isn't any particular expectation, unfortunately, that when they take Alexa out of the box, they will necessarily have a set of easily understood privacy preferences, granular settings available to them to have some to say
So,
there.
more
And
research.
by the way, about Kayla, that was a lot about children and about protecting children.
Yes,
That's how it's
I know, but there are
different.
many grown-up people who are like children, like myself. Yeah. So, please.
If I may, I would challenge the word we in the regulation. It is not the academic community who is regulating anything. It is the countries, and the countries are sovereign, and they can take decisions based on the academic ideas that they have. For example, currently India is creating its great author identity system without any privacy laws at all, and they are not going to adhere to privacy because they think that it is going to be an economic hit. So in the question that you posed, I think that more emphasis should be put on who is going to regulate AI, not that if there should be done.
Okay. Next one. You, please.
So hello, this is Attila Yavuz from Oregon State University. Speaking of cryptography, I have two questions to panelists. Number one is, how do you see cryptography and artificial intelligence interplay with each other? What are the potentials do you see there? And number two question, for cryptography, I believe we have a reasonably well-defined security models to play with. But I got the impression that from AI community, we do not have very well-defined security definitions. So given that once we compose these two, we are as good as our weakest link, how do you see this security model and definition challenges once we integrate AI and cryptography? Thank you.
Susanne, you are the victim.
Okay. I think you just defined a new program, right? I mean, these are many research questions that we have to answer. No, seriously. I mean, lots of open questions, and I don't think that we have many answers to those yet. And that's why we have the challenges ahead of us, and we ask the research community to really address them. I would go as far as, it's not just the interface with cryptography and AI. I mean, we've talked about privacy before, we talked about law, we talked about the social behavioral. So I think it's really important that we make sure that we're not just addressing this on one level, but that we're looking at this as a cross-cutting kind of a problem. And for example, if you look at the Secure and Trustworthy Cyberspace program at NSF, it's cutting across 5 directorates, and it includes all different aspects. And I think, so far we talked about it as far as just security, but now it's no longer how do you explain just security to the lawmakers or to the general public, but it's really kind of AI and security, AI and cryptography, AI and whatever. So I think we have to recognize that this needs to be addressed comprehensively.
So during the dinner, be kind to her and send your proposal. So let us go to the last part before you go all to sleep about the societal impact of AI. So one thing that most of you know is the effect of echo chamber and fake news. So first you generate an echo chamber, and then you inject, like a code injection, fake news into it. Then you will have deception, what we call today man in the middle. Yeah? And of course, there are other men in the middle. And it's very serious if you ask South Koreans. Now, this is something that is very serious in Russia. And I think one day we will all be very surprised how much effort and how much systematic effort is put in a kind of reinvention of warfare, but deception and cyber warfare. If all these news are kind of correct, like that Facebook and other social platforms, social network platforms are misused for manipulating people who have a preferred environment, and that's the social networks. I would like to go from the cyber deception to what I call cyber deflection. I think most of you know Kellyanne Conway, and I'm a big follower and a big fan, seriously. Kellyanne Conway is a counselor to President Trump. Why is she so good and genius? Because if you look at her, and if you look at all interviews that she has made, I tried to put them together. If she's requested to answer a question with certain facts, then what she does is that she takes some keywords, put them together, and generates a function which we call alternative fact. And then there is a feedback. So she models it live, online, doesn't matter in which news. There is a feedback, and the one who is the requester, the oracle that is requesting the facts as an algorithm, it will evolve into the fake or alternative fact. And at the end, what comes in as F star will be completely statistically independent of what the requester was asking. If you don't believe me, I can show you all the videos of Kellyanne Conway. That's my hobby. Yeah? So, can we build such a machine? I'm just serious about that. This is not a joke. Can we build such a machine that can immediately generate a new story, deny Holocaust? Can we build such a machine? There are people who do that. Yes, okay. I think Kellyanne Conway is the best model in that sense. So Cliff and I and another colleague from UMD, Gang Shu, we organized a workshop here at this hotel. It's not an ACM workshop. It was a workshop just by invitation on cyber deception, because this is something that is coming up in our networks, and I would like to give the stage to Cliff to say something about it.
So I think the key aspect of deception is that it's part of intelligence system. So deception is with human beings in early days. Why? Because for two reasons. One is deception serves a purpose for self-interest. So whenever you have a contest or have some kind of reasons, deception will be in play. And the second point is that what makes deception successful? The success of deception is based on the successful exploitation of the opponent's weaknesses, the cognitive weaknesses. So you have two things, right? One is motivation, and second is the possibility of reaching that, which is the cognitive or any weaknesses. So when we think about AI system, AI versus humans coming in the road in a potentially confrontational space, you could think of an AI system versus human, or AI combined with human versus AI combined with human, another team. So there's a confrontational and there's a economic or whatever self-interest involved. Deception will be part of the intelligence. So unfortunately, that will be the case. Now, just like us, you cannot eliminate human fraud. It will be part of society. But on the other side, the success of deception is really based on exploiting the weaknesses. So on the other side, the key part of a successful, resilient AI system is really the ability to learn under those kind of environment. And actually, as your example, it's really, right now, AI system does not have the capability of being introspect or being self-aware. I mean, the key part is really you will have an AI system that will be able to recognize, oops, I did something wrong. Human beings, we do, right? Directly or indirectly, we realize something we did wrong. But the AI system today probably is not there yet. Don't have the capability of being self-aware. So that's kind of going forward what is the most important part of AI research, of being self-aware. And that's just...
I just wanted to show you this, Cliff, that this is a new direction, or at least not a new direction. This is known to, deception is known to us historically, but it is cyber deception. And there are many interesting aspects in it where AI plays an important role. Let me come to the last point, and it is AI and faith. I'm not a religious person, but I want to show you a small video, because at this day I was invited to a conference from a Protestant church in Germany, Martin Luther Protestant Church, many Christians, to talk about this.
Herzlich willkommen. Möchten Sie von einer weiblichen oder einer männlichen Stimme gesegnet werden? Gerne. Welchen Segen brauchen Sie? Gott segne dich und behüte dich. Er lasse sein Angesicht leuchten über dir und sei dir gnädig. Gott erhebe sein Angesicht auf dich und schenke dir seinen Frieden. Geh hin im Frieden Gottes. Möchten Sie den Segen ausdrucken? Danke für Ihren Besuch und auf Wiedersehen.
So why is that interesting? Because maybe it comes back to one of the questions, human-machine interaction. This is very primitive currently. But this will be one day a preacher that could be much, much more advanced than this one and can manipulate any mind, doesn't matter which religion. I could put a turban on it and it would be Islamic or a Hindu preacher. And it would be a good friend because he maybe even talks to you, or you can change anything that you want to say things that you like, and it blesses you. But it can also manipulate you. And I think that's one of the most important parts of it when we compare human intelligence and human awareness with something which is with a machine. And the ethic of it.
Was a lot to say. I went to college to be a minister. And so there's also a pretty well-known Buddhist robot. It's about this big. It's very cute. That's being used in some temples. I mean, any system or robot or AI, AI can be used for manipulation, or nudging is another term. I think what bums me out is that the assumption is that faith, not that you're saying this per se, but that faith or religion automatically would be manipulative, which I know you're not really saying. But I saw the robot blessing somebody, and there's a senior who's lonely and doesn't have anyone to talk to, and they walk in and it's rudimentary, and they walk away. And by the way, just because the robot is blessing, I went to college and studied like the New Testament scripture, like Aramaic and Greek. If a robot starts to spout something that's not accurate from your place of faith, you're not going to be like, oh, it's a robot, but I misquoted the Quran, or I said that Jesus was, lived in Detroit, it'd be there. There's still going to be human reasoning. One other thing I just wanted to go back, but this relates into something Cliff said, and I wrote a book and had the question, how will machines know what we value if we don't know ourselves? Introspection is a gift that we've had through faith, whether it's a formal religion or also, agnostic traditions of positive psychology or therapy. There's an amazing opportunity for humans right now in the next 5 or 6 years, in lockstep with the amazing work being done by programmers like, to my left, et cetera, is to understand how hard it is to be a programmer and say, why did someone just exhibit something that manifests as what we would call a value? Well, you can also ask the person and ask yourself. So it's a wonderful opportunity. There's a lot of doom and gloom in these conversations, but what a wonderful time to have a renaissance. And by the way, you mentioned, if you want a great author, a guy named John Naughton, who writes for The Guardian, wrote this fantastic piece yesterday. It's the 500-year anniversary of when Martin Luther put his principles on the door of the Gutenberg Church, or I always mess them up. But he talked about Silicon Valley being a religion, and that we need a whole new set of treatises. So the faith question, I think, is a wonderful one to ask, because right now today there's also a lot of assumptions about machine intelligence, et cetera. It's faith, which I think is great. People are hoping that certain things will happen in AI. And saying to one person, well, your faith is wrong and your faith is okay, I embrace both.
So Heather, you work with technology.
No, just to build on John's comment a little bit. I think the concern here is that AI and technical systems generally do have a whiff of infallibility about them, right? So did anybody ever go to those kiosks at the mall when you were children or teenagers, and you type in your birth date and it shoots out your horoscope and it tells you all about yourself and your personality, and you think, yeah, that is me, right? That could have said probably just about anything, and you would have identified with it. And I think there's something here that's important, is that what is the trust that we put in these systems that appear to know us, appear to understand us, and appear to know the world generally, and to have a lot of information about the world that we don't possess. I wonder what would happen if you took the head off of this robot and you just interacted with it like an ATM. Would it still have the same power? I'm honestly not sure. But I think it's also important to realize that the more we engage with this at least anthropomorphized AI, maybe the less attention we're paying to developing relationships with other human beings. So I'm a big proponent of autonomous vehicles to the extent that they can help, say, the elderly get to hospitals or community centers or engage with other people in ways that they may not be able to now because they're homebound. But that also means that they're missing out on conversations with their taxi driver or the relative who comes picks them up at their home. And I don't want us to live in a world where we've substituted one set of judgments about who we are and what we need for another set of judgments, and substitutes the need for human interaction, perhaps entirely.
Gene.
I know we're probably running over time here.
No,
So
we
I
have
one,
some
I
time,
have
I
one,
think.
I have one silly question and one more serious question. My silly question is, does this robot have telescopic arms?
Telescopic what?
Arms.
I don't know. I know that
Because
this-
if it doesn't, then it's probably safer than a real priest. And my serious question is about cyber deception and the previous topic. And I wonder if the esteemed panelists consider it to be an art or a science.
Cliff.
It's
art of science.
It's science and art. I mean, it's right because for making deception, especially in the cyberspace, you need the mechanism to craft cyber artifacts and have the effective mechanism to deliver those the cyber artifacts to the target that you want to deliver to. But on the other side, there's a social cognitive side, which is the human aspect of it, which is sometimes it's an art, not science, because human beings are not computers, which you cannot manipulate in the same way with a machine, but you have to have personal touch, potentially.
Please.
I'm Sina from University of California, Riverside. I want to thank you for this great talk. And I wanted to ask you, what would be the role of human in this future that you picture? I mean, assuming that all the challenges that you discussed here will be solved, and assuming that by 2050, the computation power of a machine would be as strong as human. So what would be our role in that picture?
Scary.
Who wants to answer?
Well, I don't accept the premise.
What?
I don't accept the premise even.
Oh, you don't accept the premise, yeah.
Yeah, I mean, the premise was that by 2050, machines would be as smart as people, which I don't believe personally.
One of your panelists mentioned that.
The comment was computational power.
I mentioned computation power.
Yeah, I still don't accept the premise. I'll steal a line I heard from Andrew Ng, who said that worrying about, AI machines taking over is sort of like worrying about overpopulation on Mars. It may be a real issue, but we're a little premature on it. I think we need to learn a whole lot more than just making machines a lot faster in order to make machines intelligent. Those are quite different things. Just to, you were talking about deception. There's really two kinds. There's the kind that a lot of papers have been on in the conference on, adversarial training examples and so on. But the examples you gave were about rhetoric, that is constructing arguments intended to mislead people, a completely symbolic kind of argument. And, that's somewhat science. I mean, we've been studying it since Aristotle. But it's a different kind of research that you need to do to work on that kind of thing. You need to understand another aspect of humans, which is that we're storytellers. And telling the right story the right way can convince people of things. But you have to understand the logical structure of those stories. And it's a real art, but somewhat rooted in science, to understand how to take a story that may lead you here and to change some of the facts, some of the analogies, and so on, to make it lead you to someplace completely different. I'm not usually fair to Kellyanne Conway, but I must say that there are people on the other side who are equally good spin meisters.
Okay, please.
One feature I always bring up at these events, and people may sometimes afterwards are like, that didn't seem relevant. Well, I hope it is. The World Health Organization has a statistic that keeps me up at night because I'm a dad. It says by 2030, the leading cause of death is depression and suicide for the human race. That's, my math skills aren't very good. That's what, 13 years away? My question is the future of 2050, are we going to look back as a human race and say what we prioritized is how to use all this glorious technology to say that we will save the lives of people who are right now today, 2017, depression is a pandemic. And I only bring this up not to depress you, but to say there are actual realities that we can face today by saying, how do we put this technology to use for that? And the reason I bring that up again, and I'll just make this really clear, is it's not fair to have any community, AI or anyone else, say you should be doing X, Y, and Z and AI for good and all those things, while still underlying everything is the paradigm of exponential growth. Call me what you want afterwards, but GDP drives everything. It was created in 1944 at the Bretton Woods Conference at a very specific time in our planet. It was a philosophy. It's not that it's evil or bad, it's just not enough. You are more than your finances. Prosperity, according to Joseph Stiglitz, Amartya Sen, world thinkers, is more than just exponential growth. If, as a society, we don't support technologists, governments, and say, triple bottom line, and we don't prioritize things like depression, etc., eradicating it, then we aren't. It's pretty binary to me. So I'd love to see within 13 years, all of these discussions always talking about, are we saving the lives of our kids and of ourselves? That's a great question to ask first, I think.
Okay, and I think that's the closing amen word. Thank you very much for being on the panel and accepting my invitation, coming to Dallas in this fantastic, okay, not really fantastic hotel, but it's a very nice place to be with all these smart people. And please give a hand for our panelists.